We also have a review of y equals mx plus b in point slope form, y minus y1 equals m quantity x minus x1. Here's some review from our previous lesson, 3.3. Two lines in a coordinate plane are parallel if and only if their slopes are the same. We learned a postulate for this. And secondly, two lines in a coordinate plane are perpendicular if and only if. I'm not going to use the postulate definition, although that works too. I'm going to say their slopes are opposite reciprocals. That means if you see a positive, the slope becomes negative. If you see negative slope, it becomes positive. Also, if we're talking about specifically slopes and reciprocals, say we have 6/7, the reciprocal of that would be 7/6, and with the slope, you got to change the sign, so it would become -7/6. So we are going to write an equation in slope-intercept form, that is y equals mx plus b, for a line specifically perpendicular to this line, y equals 1/5 x plus 2, through this point. That sounds like a lot, right? It's not really too bad. We first need to state what our perpendicular slope is. So we know we need the opposite reciprocal of 1/5. So that means we will have -5. So our new slope for our perpendicular line is -5. And we must have that new line through the point 2, 0. So I'm going to plug these things in. 2 is my x value, 0 is my y value. So I have 0 equals -5 times 2 plus b. So 0 will equal -10 plus b. Add 10 to both sides, and 10 will equal b. So I plug in my slope value, my b value, and I have that my perpendicular line will be y equals -5x plus 10. Now I'm going to show you this on a graph. It's going to be a quick sketch here, not perfect. Our original line was 1/5 x plus 2. So I'm going to plot that. I'm going to start at plus 2, and then I'm going to go up 1, run 5. So it's going to be right there, and then I'll go down 1, run 5. Right here, and then I will draw a line as best as I can. That is my original line. Now my new line must be perpendicular to that through to 0. So let's check to see if this works. So my perpendicular line starts at plus 10. I have -5, so come down 5 and then go to the right 1. Then I'll do that again, come down 5. I think I must have 11 lines. I do. Here we go. Up 10, come down 5, over 1, over 1, draw in my line. These are perpendicular, and it does cross right here at 2, 0, so we are good to go. This is our perpendicular line through 2, 0. Now we are going to, once again, write an equation, slope-intercept form, very similar, perpendicular to this line through 0, 8. Very, very similar. First, need to find my perpendicular slope. If it's 1/3 normal, it becomes -3 perpendicular. Now, this plus 2 Mixes a lot of students up. You don't really even need that when we're writing our new line. We really only care about the slope from the old line, so don't let that +2 confuse you. Now, to make our new line go through that point, I have xy, so we have 8 equals -3 times 0 plus b. Solve for b. b will equal 8. Plug in our slope, plug in our y-intercept. Y equals -3x plus 8. You could go ahead and check what I just did on a graph, make sure they're actually perpendicular. I will tell you that they are, but you can check if you'd like. Now, this time it says just write an equation. That means we can use point slope or slope intercept. I'll show you both. And it's of the line that passes through the point 4,5. This time parallel, very important. And this is our original line. So once again, don't let the +6 mix you up. You don't really need him right now. All we need to look at is the slope of the original to find our parallel slope. So we could say parallel slope, that just means parallel lines, maybe put them at a slant more. Or you can just say the slope is the same, so it is -3. So now I'm going to do point slope to start with. Our point slope form is y minus y1 equals mx minus x1. So I have x1, y1 here. I'm going to plug them in as well as my slope. So x1 is 4, y1 is 5, slope is -3. So this is already done. That is my point slope form. To solve for slope intercept form, I go ahead and distribute -3 through, so I have -3x plus 12 equals x minus 5. Add 5 on both sides, and we get y equals -3x plus 17. And this is my slope intercept form. So you could once again check this on a graph, make sure that this is actually parallel to our original. It is going to be parallel because the slopes are the same. So we are good to go. This next slide is a key concept about horizontal and vertical line equations. If you watch 3.3, we covered this briefly. The equation of a horizontal line is y equals b, where b is the y-intercept. So in this case, y equals -3. For a vertical line, x equals a, where a is the x-intercept of the line. So in this case, x equals -2. And we had a postulate on 3.3 that said a horizontal line is perpendicular to a vertical line. Makes sense. So we are going to write an equation of the line that passes through the point -3, 8 and is parallel to the line y equals 6 and parallel to the line x equals 1. Now these guys kind of get confusing for me, so I would suggest graphing these as often as you can just to visualize them. So we want our line going through -3, 8. So it wants to go through that point, and it must be parallel to y equals 6. So y equals our horizontal lines. So it must be parallel, which means it's another horizontal line. It crosses the y-axis at 8, so our parallel line will be y equals 8. Now notice, in our coordinate, y will equal 8. Pretty nifty. On the next one, we want to solve for a parallel line to x equals 1. So it must be parallel to this line. which means it'll be another vertical line. We want to see where it crosses the x-axis. So we have x equals -3. Notice once again, in our coordinate, x is -3. So they're pretty easy if you can visualize them, like we do on the graph. This time, we want to go through the point 5, -2, and write an equation that is perpendicular to y equals -1, and another one that is perpendicular to x equals 4. So 5, -2, go ahead and plot that. I'm going to draw in my line y equals -1. So if I want a perpendicular line through this, that means it is going to be vertical. So it crosses at 5. So our perpendicular line is x equals 5. Notice that here. And lastly, we have the line perpendicular to x equals 4. So x equals 4 is a vertical line, which means our perpendicular line will be horizontal. A horizontal line is always y equals, and we know it crosses the y-axis at -2. Once again, -2 is what our coordinate is for y. So if you can look at those and recognize that, you know that perpendicular to x equals 4 is y equals -2. Have a great afternoon.